Okay, so question 2 here, very similar actually to question 1. Okay, so we've got here the value of an investment, maybe modeled as a continuous variable. Of course, an investment usually increases, doesn't it, right? And they say that here, don't they? The rate of increase of V is directly proportional to the value of V. So the rate of increase means that it's increasing, and of course we look at the gradient function of it then, yeah? The gradient function is going to be positive, isn't it? Yeah, because it's increasing. It says that. So the rate of increase we can write as dv with respect to time. It's going to be time, isn't it? Because it's about it increasing over t years in that sense. We're looking at the gradient function of that. This is the gradient function. It's going to be positive. All right. The rate of increase, it's saying, is proportional. So we use the fish symbol to the value v. Okay. So we've got that there. And then to write an equation for part A. Okay, differential equation. Of course, we need to change this to an equals, right? But when you change it to an equals, we need to introduce a constant of proportionality, which is just that letter k, right? So we've got that there. So part A is answered. We've got 1 mark. But to get part B now, we need to get that sort of formula, if you like, for the value v, where A is introduced here. Okay, that's not a problem. So we need to essentially integrate this gradient function here, and we do that by separating the variables. Okay, we need to get the v's onto one side. At the moment, we've got v here and v here. That's no good. So if I take the v over, because you times in k times v here, if I take it over, I'm going to divide. Yeah, I'll keep the k where it is, and I take the dt up here. So I've got that. Okay, but of course I need to integrate. That's the idea of separating the variables then, so we can actually integrate it. And we can establish then what v is. Remember before, this is like 1 over v, yeah? 1 over v dv, so that'll be ln v when I integrate it. K is a constant, so constant integrated with respect to t, it'll be just kt, right? And then of course you've got another constant then of integration, which is plus c, okay? So we need to put that one on there. Now, we want it in that form where E is formed, and we want V equals. So to get V on its own, you need to appreciate then, while we take the ln over, and if we take the ln over, we're going to E this side, right? Okay, when you take ln over, you do the inverse, which is E in. And then, you just like before, using rules of indices, because you're adding powers, this is the same as timesing the terms, okay? Right, and then we need to appreciate then e to the power c, it's just a constant, isn't it? Okay, e to the power c, it's a constant, so we can just call it a, right? A constant. C is a constant, so e to the c is a constant, so we just call it a. So we say therefore v equals ae to the power kt. Okay, there's our answer there. Now we've got then part C. Okay, so the value of investment after 2 years is £292, and the value after 28 years is £637. So what we can do now is, with my formula, we can actually just put these values in. So v equals ae to the power kt. Okay, so after 2 years, the value is 292. Okay, so t is going to be 2, so that'll be 2k. And then after 28 years, the value is 637. So, and t is going to be 28, so k times 28 is 28k. So equation 1 and equation 2, right? And what I can do now is, of course, is divide. 2 divided by 1. So I'm going to have this divided by this. And then this divided by this. The a's will cancel. And then I just got this, I don't know what that is, but in this case here, you take away the powers, yes? That'll be e to the 26k. So if I just type that into my calculator, it might simplify down to something nice. Type that in there, I don't know. No, it doesn't, so we'll just leave it as it is. Okay. The next thing then, of course, you need to take the e over, so we'd be ln then of all that will equal to 26k, yeah? If I take the e over and ln, 26k, then of course I divide by the 26 and I can get my k out, and it should give me 0.03 as we're looking for. So let's just check ln 637 over 292 and then divide that by 26, and I get, yeah, 0.03, quite nicely, isn't it? Exactly as they want, 2 decimal places. Okay. Then it says find the value of a, correct to the nearest integer. Correct to the nearest integer, so we can round that. So what I do then is just simply sub it into, say, number 1. Okay. So maybe I can put it in here. So so sub into 1. So 292 equals to a, e to the 2 times 0.03. Okay. So then to get a, I just got to do the 292. Of course, if I just take all this over and divide, e to the, well, that's going to be 0.06, isn't it? Okay, so if we write another bracket and so on, just times by 2. So that'll be 292 divided by e to the 0.06, and I get out, now it said the nearest integer, if you look there, right, £274.99, for, yeah, it's £275, isn't it, basically? Okay. Alright, 275, so that's the value of a there. And then it says find the initial value of the investment, giving your answer correct to the nearest integer. Okay, nearest pound, it says. So if I rewrite v out now, 275 is what a is, e to the kt, now k is 0.03, so I'm using these two values for a and k, t. Now initially, it says find the initial value is when, of course, t is equal to 0. Initially means at the beginning. So we say therefore v is equal to 275 times e to the 0.03 times time, which is 0. And of course that would be e to the 0, which is just 1. Okay, so the initial value will be what a is essentially. Okay, it will be the value of a, which is £275. Yeah. Job done.